So you're probably wondering what this is going to be about. We'll get to that. So my name is Beth. I am a Ruby engineer by day. And I'd like to warn you all that in the next 40 minutes or so, you're going to encounter some poor singing, too many cat gifs, and an excessive amount of silliness. So let's get started. And hopefully this will, there we go. All right. So I've been told by people that one of my strengths is thinking outside of the box. Or as I like to call it, coming up with really bad ideas. So some of my bad ideas have included Feces Book, a social media website for your poo. There's kombucha, really boozy kombucha. And if you don't know what kombucha is, it's like a fermented tea drink. Another idea is birth announcements, but for features that you release at work. I don't have a name for that one. Another one is a Meowifier. So a Meowifier is a US-based antisocial network for your cats. And I ended up releasing it to a smaller market in Omaha, Nebraska, where I live. It's called Meowha. It's up online. You can find it. So slight change of subject, but still fairly relevant. Who here is familiar with Game of Thrones? You should raise your hand. I think you should most of you should be after Ray's talk yesterday. So I'm going to give you a little bit of background about myself. This is me and my husband getting married. These are two of our cats, so Xiaogui and Clementine. And this is Gita. So we're a multilingual household. And this is us. We really like Game of Thrones, okay? I think this was like right after the first season finished airing, and like back in 2011. And Halloween is really big in the US. Like for those of you who aren't from there or who haven't lived there, like everybody dresses up. So it's not like we were the weird ones. Like everybody was, well, we were, but hey. So pretty good. I mean, almost identical likenesses. You can barely tell us apart, right? So right now, you might be confused about why I'm sharing all of this information with you. That's okay, because I'm going to play you the Game of Thrones theme song. Okay? So you guys all recognize that, right? So it's an instrumental score, right? There are no words. Well, there are if you add them yourself. So this is going somewhere. One Sunday night when Game of Thrones was airing, we were listening to the Game of Thrones theme song, and nothing was happening. You know, it's a regular old theme song, and we're like, it really needs some lyrics. And so we started doing something, and it just caught on. And now it's a tradition in our household. And so we're all going to do it together. And what we're going to do is we're going to meow the Game of Thrones theme song. And I'm going to get us started, but you're all going to join in. All right, so it goes like this. Meow, 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 meow. I would keep going. I go the whole song. I don't get bored. So that was us. We were singing the Game of Thrones theme song. So we basically, what I like to call, meowified the Game of Thrones theme song. And we probably set some kind of world record there. So anyway, Meowifier, that's what we're here to talk about. Meowifier is my application. And it's just one bad idea in a long line of bad ideas that I decided to build. And it also seemed like a really interesting problem to solve. And I finally said, about 2 years ago, I said, what the hell, I'm just going to go ahead and build it. So how does it work? Well, you upload a song, like an MP3 or a WAV file, and it outputs the song's melody in meows. So I wish I could say there was such a thing as a cat choir, but I Googled it, and there was no such thing. So it was all up to me to figure out. But in my history research. It's like my favorite. So I found quite a few historical cats and musical cats, and I discovered that I was not the first person to come up with this idea of a cat chorus or a cat choir. This is actually a cat organ. In the 16th century, a historian described seeing a cat organ being played by a bear when King Philip II rode into Brussels. I don't know if it was true or not, but a historian wrote that down, so I'm going to trust him. And then in 1650, there was a German scholar who said that a cat organ was made in order to raise the spirits of some prince. So another example, 1803, there's a psychiatrist who thought that there was a medical potential for the cat organ, and that was people who were mentally insane, that they would possibly respond to a cat organ because the only thing a little bit more insane than their own brains was like seeing cats being played as an organ. I don't know if that makes any sense, but despite all these historical records, scholars are unsure if anybody actually ever built one. It was likely just a hypothetical instrument, and it would have made terrible music anyway. So cats don't meow in like a set pitch, but until now, that is. So let's do this. I had some big challenges facing me when I started building this application. And I also had momentum. So I decided to go ahead and get started before I actually knew how I was going to solve these problems. And one of the ways I set some standards for myself, because I knew this was going to be a hard problem to solve. So I had read Pooter, Practical Object-Oriented Designs in Ruby by Sandy Metz. If you haven't read it, I highly recommend it. And I knew that I needed to make my classes really, really stupid. So that's what I did. And I also decided that this application was going to be 100% test-driven development, because I've dealt with enough legacy code that was untested for the entirety of my life. I don't need any more of that. So I had a couple of standards in place. And then I had these 3 big challenges that I had to figure out. So 1, finding a way to obtain the notes of only the melody of a song. 2, correcting my note lengths to match the length of the note in the melody. And then 3, creating this multi-octave library of meows. So let's get started. So the melody. It's pretty easy for a human, especially one with musical training, to pick up the melody of a song. So for those of you who aren't musical, the melody is the principal part of the song. So if you were listening to Bohemian Rhapsody by Queen, it means that, well, let me just sing it for you. So the melody would sound like this. Mama just killed a man, or I see a little silhouette of a man. So those are the melody. That's kind of hard to pick out when you're a computer. And I didn't want the harmony or the bass or anything else muddying up the melody. So what did I do? Well, computers are pretty dumb. So writing an algorithm that a computer could use to extract a melody is really, really difficult. And you're probably wondering, well, Beth, did you write a musical melody analysis algorithm? No. I'm a programmer. That means I'm super lazy, and I'm going to go look on the internet first, which I did. So it was so hard to find a melody analyzer, but I did. I found one. The first tool that I tried is called Sonic API, and it offers professional-grade audio technology. And it was free up to a certain amount, so I was like, I'm going to give this a shot. So this is from my song parser class. I have a method called parse, and it just makes this API call out to the Sonic API, and then returns song file, or it returns a collection that I'll show you in a second. So it returns this response. Except imagine this is hundreds of lines long. So this is actually the beginning of the Game of Thrones theme song. Let's take a closer look at one of these. So we've got 4 pieces of data. So MIDI pitch maps to the pitch of a note. And because only whole MIDI pitch numbers map to what we think of as standard notes on a keyboard, I had to round the note up or down before I could map it. So this MIDI pitch, for example, would get rounded up to 36. So let's see what that gets us. So here's a MIDI map. So MIDI, which is short for musical instrumental digital interface, is a technical standard that allows electronic musical instruments from different manufacturers to communicate with one another. So 36 lands at C, 2 octaves down from middle C. So C4 is the middle C. And then if you're musical like I am, I play the piano, I'm a percussionist, so it helps me to visualize these notes on a keyboard or marimba or xylophone or whatever. So if we wanted to play this note on a piano, this is where you would find it. And then the great thing about MIDI, it's standardized. So I just went ahead and made these constants in my application. So this comes into play after I've parsed my song. Again, here's that MIDI pitch, 36 and C2. This is just a butt scratch break. We just looked at a lot of coding slides. So I end up appending my array with the note that I just found from my parse method. So I'll show you what that looks like. So you remember this collection? So I append that to look like this. So now I have 5 pieces of data in my hash. And if you've got the whole collection, this is what it looked like before. Now, it's just got one little piece of information tacked on to the end of all these, which is very helpful. So what's next? So you're looking at this, you can see there's a MIDI pitch, onset time, duration, volume, note. Well, if you guessed duration is next, you were right, because I need to correct the meow length to match the length of the note in the melody. So a melody is going to have notes of varying lengths, and I'm going to do a little bit more singing here in a second. But when you think back to Bohemian Rhapsody, Freddie doesn't hold each note for like half a second. It's not, Mama just killed a man. It's, Mama just killed a man. You know, those are very different note lengths. So I can't have a library folder holding a meow of every conceivable length and every conceivable pitch. So it'd be a bloated monster of a library. So instead, I had to find a tool that could help me either cut or extend an audio file. So again, I'm a programmer. You're all programmers. I'm going to find the laziest, easiest way possible to do this. And I need to find a tool that can handle multimedia files. FFmpeg. I'm sure plenty of you in the room have used this. It's like almost 20 years old. The only problem I came across is that there are almost too many configurations and arguments when you're setting up the options for this. I spent a lot of time on Stack Overflow finding exactly what I needed. And this part probably took me the longest to build out of anything that I worked on in this application. I finally got it working, though. It's kind of a messy method, this meows method. So Sandy Metz would probably not be happy with this method, but that's OK, because she's not here. So it's a little hard to determine what's going on here. Like I said, it took quite a while to figure this part out. And by the time I was done. So I'm going to walk you through it. And I promise I'll refactor this eventually, right? It's a side project. It'll never get refactored. So we're going to pass in our parsed song. And the parsed song is that collection that the API returned, and then we append it. So this is my collection. This is my parsed song. And at this point, I need to tell you that there is a library of meow files in my application. We're going to talk more in depth about those in a little while. But all you need to know right now is that there are approximately 88 short audio files, each with a meow in a different pitch, like the ones you'd find on a piano keyboard. So this is the part of my code that creates a meow with the correct duration. So this first piece of logic is the if statement. This is what shortens my notes. And the else statement is what lengthens them. So let's talk about short notes first. It was pretty simple. I didn't have to do a whole lot. All I had to do was make a copy of the meow file in my library and then cut it down. So this is my note duration that I need in my song, 48.48 seconds. And then the note to adjust, which is my library file, is 1 second long. So all I need to do, cut that down to 46. I think that says 48. Ignore the numbers. So cut that down, and then I'm done. So long notes are a different story. This one, there are a lot of different ways I could solve this. But what I ended up doing was, if the length of the extracted note is longer than the meow length, I would keep duplicating my meow until it's longer than the extracted note, and then combine those meows together and cut them down. Don't worry, I have a diagram explaining all this. So this is my code that I wrote for this part, for just to lengthen a note. And this was actually a lot of fun, probably my favorite part. So you find the number of loops. So the note length is the length of the meow in the song. So I need a 2.4 second long meow. But my file meow is only 1 second long, so I grab 3 of them and then combine them together and cut them down. So pretty easy, right? Well, it wasn't actually getting to that point. It was not easy, but now that it's done, I'm like, yeah. Oh, man. That's a close-up one. It's hard to see. Oh, there we go. Wait, I got to get this. I want to get this one playing. Oh, it's not going to be full screen. That's OK. Anyway, so all of these files get stored into my notes file. And then what I end up doing is I combine all of those files together in my song builder class. Again, I think I'm using FFmpeg here a little bit. So what's next? My meow library. So there's a lot of meows, if you haven't noticed. So in a piano keyboard, there's 88 notes. And if you haven't noticed, very few cats meow in like tenor, baritone, or in the bass ranges. So like, where does one hire a cat choir to begin with? I don't know. So I had to figure out how to find a custom library of meows. And I used some interesting tactics. So the first tactic I used. So I sat at my piano, and I played a note, and I just tried to sing it while recording it on my phone, which didn't work out very well because I'm always a tiny bit flat, and my piano is always a tiny bit flat. So it was pretty off. So I was like, this isn't going to work out. So my next step was singing into my laptop's microphone. And I was holding like a tuner app on my phone. So it was like, la, like C. OK, cool. And I think I got like half an octave's worth of notes before I was like, this is not cutting it. But I wanted to test out my application at this point. It works. So it's very exciting. I fortunately knew a song that only had 5 notes, the 5 notes that I recorded, and that's Jingle Bells. So my test passed. That's great. But what was I going to do for like the other 80-something meows that I needed? Well, back to the dark, deep edges of the internet. So many references to keyboard cat when I searched those. But I finally found a few octaves of an auto-tuned man meowing on like a free sound like website. It was like, you know what? I'm going to go for it. I'm just going to use these. So here's this library. So I've been saying a keyboard has 88 notes. If you're looking at this, you're probably thinking that's not 88 notes, and you'd be right. It's only approximately 4 octaves worth of notes. So on the keyboard, this is what I've got right now. Not ideal. But what was I going to do if one of the notes fell outside of the range of these 4 octaves? Well, I'm going to write instead of making more meows, I'm just going to adjust the octave designator to be a note in a different octave. So for example, if I had an F7, I would adjust the octave down to F6. So I'd subtract 1 from that octave. And there's a lot more code that you're not seeing behind the scenes. But this is the easiest way to show it. So that was one solution. But you'll also notice that, so each note has a pitch and an octave. And then you'll notice some of these notes have a hyphen in between them. Yeah. That is supposed to be a sharp. And if you probably don't remember, but my note mapping constants are all in sharps, not hyphens. And I'm like, OK, I could either go through all of my meow files and adjust the hyphen to be a sharp, but I'm too lazy, so I'm just going to write a method that formats those notes for me. And that's what I did. So I formatted my notes. I found the right note. So I've got this library of this man meowing. Meow 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 meow. Okay, it still works. That's cool. But I still wasn't happy. I really wanted this to be meows. I wanted to have a broader range. And so I finally just bit the bullet. I was trying to be lazy, okay? I was trying to be a programmer and find a way around all this, and I'll just make my own meow library, and that's what I did. So I made 88 meows. I took a cat meow and I auto-tuned it 88 times. That was fun. So I thought about writing a program to do that for me, but then I'm like, I think that would have taken longer than just recording and auto-tuning these. But what it allowed me to do was get rid of some code. So I named the notes using sharps, so I didn't need this format note method anymore. And I could get rid of this set octave modifier because I had all these notes now, which is great. So the moment you've all been waiting for. Almost. I just got to remind you. So this is what we're going for. Okay, the Game of Thrones theme song. That's why I did this whole thing. Thank you. There are some problems. I don't know if you noticed that, but that didn't sound anything like the Game of Thrones theme song. What was going on? Well, my melody analyzer was what was going on. This is what happens when you use free melody analyzers. They don't do such a great job. I was like, well, this is a bummer. I am going to try again. I'm going to find that melody analyzer that works. So I found a melody analyzer called Melodia after who knows how long searching on the internet. And so this guy wrote this repository, and he has his PhD thesis in melody analysis. And he developed software and a command line tool, and it was free. So I thought, what the hell? All I had to do was sign a release form before the university where he got his PhD would let me use the software. I'm not sure if they actually read the form before they sent me the software, because this is what I submitted. Who knows? But here's my command. So this is like the command that runs the whole process. And I just output it onto my desktop. I was just testing it. I wanted to see what happened. And it ran really fast. And I was like, that was a really fast melody analysis. But I was like, yeah, awesome. This is going to work. I'm excited. So the difference between this software and the previous API that I was using is that this one outputs a MIDI file. So I'm like, cool, OK, I'm going to have to build a class that translates MIDI files into like WAV files. No big deal. But before that, I decided I would test out this file in like one of those free MIDI like analyzer programs online. So I won't go on. So that was Melodia in action. So let me explain what you're looking at. This is also Melodia in action in diagram form. So blue is the frequency that the melody actually is. Oh, wait, sorry. Blue is the frequency that the melody extraction analyzer estimates the melody to be, whereas red is the actual melody. So if you're looking at these, jazz, it works pretty well for jazz. It sucks for pop and opera, and for Game of Thrones, apparently. So it turns out it wasn't going to be worth my time to add this whole thing to my application. So I'm not too happy at that point. I decide I'm going to go back to Sonic API. And so I'm stuck with this. OK, is it perfect? Well, you tell me. No. Like, you don't even have to tell me. It's so far from perfect. But like I said, this is the side project. So I'm not getting paid yet. So we'll see. There's no due date. I'm going to keep iterating on it. But I'm hoping someone eventually introduces a better free or cheap melody extractor. So what's next? Well, there's a lot of changes I still want to make. Like, I haven't actually finished out the client side. Like, you can go to meowifier.com, and there's like a landing page, kind of. But there's no way to input a song yet, because it sucks. I mean, you just heard it. It's pretty crappy. I want a better melody analyzer. And there are some really good ones out there. The problem is they're super expensive. And like I said, I'm not getting paid for this. So what am I going to do? I'm going to pivot, like any good startup does, but just slightly. So have you heard of SHAZAM? So SHAZAM is a song identifier app. So what it does is, like, you can like hum a song, and Shazam will figure out which song it is. So my idea is that I use software, like a reverse melody analyzer software similar to Shazam, to figure out which song a user is uploading to my website. So I use Shazam, analyze that song, figure out which song it is. So if it's the Game of Thrones theme song, I go out, my application will go out, technically, scrape the internet for a MIDI version of the Game of Thrones theme song, and then translate that MIDI version of the song into cat meows, meowifying it. Success. I hope. I haven't done this yet. That's like the one thing I have left to do. So, like, I'm kind of a failure. It was kind of funny. The first time I gave this talk, afterwards somebody came up to me and was like, wow, that was so brave of you, getting up, showing everybody how badly you failed. I was like, that's not really what I was hoping you'd get out of it, but cool. So what am I going to do? I'm going to go ahead and build that MIDI version of it where I scrape the internet. I also figured out, why not? I'm going to go ahead and I'm going to start saving all of these analyzed songs on AWS, so that next time somebody uploads the Game of Thrones theme song, instead of actually having to go through and analyze it, I can just output it right back to them. Saves me time, saves me money, and it makes it faster for them. Better user experience. And in the meantime, I'm not done searching for a good free melody analyzer, or cheap, we'll see. And with that, that's all I have for you. Maybe I'm a failure. I'm not done yet. We'll see. So you can find my slides on slide deck. You can ask me any questions right now or on Twitter. I've got my code on GitHub. I write some articles on Dev2 sometimes. I have my own website, bethanyhaubert.com. And I appreciate you listening to my failures. Thank you.